Hi, everybody. Welcome to today's webinar on energy systems and managing costs. All of our PGE seminars and webinars are in part sponsored by the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance. We work together to make sure the concepts and recommendations you learn in our events are consistent across all our individual programs. We don't want our customers to get any confusing information. And I'm trying to advance. There we go. So today's agenda, we're going to talk about how electricity is measured, how we calculate energy savings for our typical energy efficiency project, how do we do a simple project evaluation, and at the end, my favorite and best advice is, who do I call? Where do I get extra help? So why focus on calculating and measuring? Well, why learn about measuring? Measuring anything starts with a focus, managing anything starts with a focus on measurement. This is a picture of our friend Peter Drucker, one of the best read management texts. And you notice that there's a chart. We're going to talk about charting. We're going to talk about measuring electricity. And the bottom line is what gets measured can get managed. So if you want to reduce those bills, you need to figure out the measuring systems. The other thing you might see in other programs and services offered are things like a management cycle. This is called the Plan, Do, Check, Act cycle, PDCA. It's very common. You may see it in the form of a Lean Six Sigma or strategic energy management. But I highly recommend that measurement is a major part of completing that cycle, especially in the planning and the checking phases. So we'll keep this in mind today as we go through the webinar. So to get started with definitions, how do we measure electricity? There are three important concepts you'll need to know out of the many that are around. One is the mighty volt. The example most often used to teach about volts is the garden hose example at your house, the water system in your house. If you want to take a shower and everyone on the street fires up their sprinkler systems, you might have a low water pressure issue. The water pressure would be equivalent to a low voltage problem in the electric system. So volts is about the amount of force applied to electricity to get it to move. The second example is the mighty amp. And the garden hose, if you want to move a whole lot of water from one place to another, or you have a whole lot of sprinklers on your system, you need a larger hose to carry larger amounts of water. In the electricity side, larger wire sizes carry more electricity than smaller wire sizes of the same metal. So the size of the wire is all about how many amps are being carried, just like the garden hose. My best example is when the fire truck pulls up in front of your house. They have, A, a lot bigger hose, and B, they run it through a pumper truck to get even more pressure. So when you combine those two, the pressure and the volume, volts times amps, you will get the mighty watts. And this is the key term and measurement system for managing electricity. Volts times amps times watts is the formula for single phase. Residential and most commercial operations have single phase service. It's a little more complex. We won't talk about them today, but I wanted to introduce some terms you might see, and that is three-phase services for larger commercial and industrial. If you take volts times amps times the square root of 3, a constant number, times something called the power factor, you will get watts. Now the power factor for 99% of our customers is considered to be 1. So anything times 1 is itself. So quite often it's left off the formula. But for very large customers, especially ones with large amount of motor load, you will find power factors significantly less than 1, 0.8, 0.7, 0.6. So you might have a power factor issue related to your energy use. But again, that's a very small number of customers. And then, of course, all this comes out of something called Ohm's law. Ohm is the amount of resistance to the flow. So as we try to get those amps to move across those wires, there might be some resistance, and the resistance is measured in terms of ohms. So these are the terms that are important for this course.
Hey, John. Which one of these terms will a customer actually see on their bill?
That's a good question. Everyone will see the watts or W's throughout their bill. They may see watts in the form of demand charge. You may see watts in the form of watt hours for the amount of energy you use. But some people, especially the power factor bills for the power factor is an issue, you will see the volt and the amp, something called kVAR, K-V-A-R. But we're going to focus in on the mighty watt that everybody's bills is going to find on it. So when we look at the bills, about 90% roughly of your energy bill is going to be a price times kWh. And kWh is this really interesting acronym. If we talk about the Trailblazers and we say they belong to the NBA, we know that that's the National Basketball Association. So a single organization has a three-letter acronym. In this case, kWh, it does not stand for one thing. It's three separate concepts laminated together. So let's separate those out. The first part of this acronym, the K, we go back to our science and math classes in junior high and high school, and it's the mighty metric system. So the K stands for 1,000 or 3 zeros. If you saw an MW, you'd be a million watts. If you saw a GW, a billion, a trillion, and so on. So the first part is simply how many zeros do I want to put in front of the W. In this case, kW would be 1,000 watts. The middle part is watts for your bill, but it also could be V or A or an O or many other characters. So the first part is the unit of measure. If you're talking to a consultant or an engineering firm and they want to give you some recommendations about your system, you may be talking in terms of kV for 1,000 volts. And the third part, of course, is the unit of time. Once you've purchased your equipment and the wattage is fixed in place, then the issue is, well, how many hours do I use it? If I use it for 100 hours, that would be 100 watt hours. Sometimes you may see the letter A after as a third part, and that simply means on average, annual or average. And that represents, for example, if you had an exit light, it's on all year long. That's 365 days times 24, 8,760 hours per year. So this is your basic sheet to kind of keep up with all the terms you may hear in conversations about managing energy or your system, as well as what you might see on the energy bills. So we always need a formula, a little basic algebra. To come up with kWh, we take the watts. You're going to find that on the label. Federal code usually, almost always requires there's a label on the equipment that tells you how many watts this device uses. You may also see volts and other things, but the watts is what we're concerned about. We immediately divide by 1,000 to get to kWatts, and then times the hours of use. And the hours of use is the single item that I find most customers have the least amount of knowledge about how many hours a piece of equipment is being used. So let's look at a quick example. For example, if I had 20 100-watt light bulbs, I would take 20 times 100 and get 2,000 watts. So I've found my W in my case of an analysis. I know that if I divide by 1,000, that would give me 2 kWs. And then if I take it times 1 hour, that's 2 kWh. So this system of 20 100-watt light bulbs uses 2 kWh for every hour that it's on. So let's try a little example. We can now use our arrows or a checkbox or one of the fun tools up there and tell me how many kilowatt hours are used by a 60-watt light bulb that is on 10 hours a day for a billing period of 30 days. Try to apply the formula and put your arrow near what you think the answer is. And while you're doing that, I'll tell you a little story about the little light bulb. I've asked you about one light bulb, but I had a customer I spoke with was an auto dealership, and you've seen them along some of the major boulevards, lots of lighting, and they counted the number of bulbs, and he had about 1,000 bulbs was the final count. The monthly bill was about $864 a month for all those bills. So changing out to a lower wattage could mean quite a bit of a reduction in his electric bill. So let's look at what you've come up with. We have we've got a couple of choices it looks like. So let's see how I did the math here. I took 60 watts, divided by 1,000, and my hours were 10 hours a day for 30 days, or 300 hours. So I would get 18 watts would be 18 kilowatt hours would be the amount of energy used in a month by a bulb. And of course, I would immediately suggest, we know incandescent bulbs are tougher and tougher to get, and there is better technology. So let's assume that I'm going to change this to a compact fluorescent, and it is only 18 watts. And I'm going to try to clear the annotations. So let's now recalculate with the 18 watts bulb and see what do you think the math is there. And then while you're doing that, I'll tell you a second story of a multifamily apartment complex and talking to the property manager. And although there was about 100 units, it was a large complex, and each unit has its own electric bills and electric meter. The landlord's electric bills included the hallways, the pathways, the parkways, common areas like the laundry room, and they were all part of the landlord's electric bill. After taking inventory, he had about 600 light bulbs. So the potential savings that he could get, again, were quite significant. So it looks like you've all applied the math pretty well here. And in fact, that's exactly what I would get to. 18 watts divided by 1,000 times the number of hours in the month, 5.4 kilowatt hours. Everyone in the class gets an A. So here's another example of where you might find the formula interesting. You can use your raise the icon symbol when you know, we're going to play Jeopardy here, 100,000 million, I always have to recount, 1,210,000,000 watts is the answer. What's the question? And I'm going to give you some hints and see how long it takes before everyone gets the answer. So far, no one knows the question. How about this hint? Does anyone know the movie that I'm thinking of here? All right, I'll give you another hint. I don't see any hands raised. Of course, this is an electric vehicle. So here's the answer. Where am I going to get 1.21 gigawatts? This is an electric vehicle, time machine. That's a flux capacitor in the lower left-hand corner. And of course, Doc couldn't figure out exactly where he was going to get that kind of power back in time. And Doc Brown was scratching his head and going, where am I going to get it? And of course, I did the math, and lightning, in fact, is where he found his power, and it is in the range of giving you that kind of gigawatts. So even in the movies, sometimes our formulas can be useful. In this case, if I asked you how many kilowatt hours does it take to charge this electric vehicle in 1 second, You could do the math now with the formula. At the top you can see I take the watts, I divide by 1,000, and for the hours it takes 1 second to charge this. There's 60 seconds in a minute, 60 minutes in an hour. So that's 1/3600th of an hour. If you do the math, it takes 336 kilowatt hours per charge per trip in the time machine. If you were paying, say, 10 cents a kilowatt hour, to keep the math simple, it's about $33.60 per trip. This is pretty economical. Sometimes I wish this was a reality, but who knows what happens 10 years from now. So sometimes it isn't going to come to you as watts. You may hear the conversation about tons of air conditioning or tons of refrigeration if you're a grocery, or horsepower is another common term, and you need to convert that to watts. And this is an important measurement. In the case of air conditioning, 5-ton air conditioner, there's something called the energy efficiency rating, or the seasonal energy efficiency rating. So these two terms here, and there may be other efficiency ratings. The importance of this formula is a 5-ton air conditioner at 12,000 and at 10 energy efficiency rating is 6,000 watts for every hour of use. Here's an identical air conditioner that still puts out 5 tons of cooling, but at 14 EER only uses 42 and 86 watts, significantly less. So if your purchasing manager comes to you and says, wow, I got a great deal on a 5-ton air conditioner, your next question should be, at what efficiency? It may be that they thought they got a good deal, but it just locked in a lot higher bills, 40% more energy for each hour of use for this unit for the next 15 to 20 years. So watch out for the efficiency ratings when you hear about tons. Horsepower, we have exactly the same kind of formula. We have 5 horsepower times 746, a constant, and then you divide by the efficiency rating. Again, that's going to be on the label or somewhere on a list where you know you can get at the efficiency. And again, 2 5 horsepower motors both put out the same amount of power, but one uses significantly less amount of energy. So watch out for efficiency ratings on equipment when you purchase it. So let's talk about circuits. We mentioned earlier that the volume of amps going through a line is determined by the wire. One of the determining factors is the wire size. So here's a choice of a customer. It's 2 60 horsepower motors. They both are labeled 48,000 watts. One is a 480 volt system, and the other one is a 240 volt system. And if we look at the volts times amps, they both are 48,000 watts. In one case, 480 volts times 100 amps versus 240 volts times 200 amps. 200 amps is going to take bigger wire, which leads to bigger installation costs and future line losses. If this piece of equipment is far away from your service panel, the cost of wiring is going to be significantly higher for the motor that takes 240 volts than the motor that takes 480. Other things you might hear is you have an amp problem in your panel because you are reaching a capacity, and I've seen energy efficiency projects like lighting and like motors that you can change out equipment and save a significant amount of amps. If you had an old motor at 240 and you replace it with a motor that's 480, you just saved 100 amps in the panel. So keep an eye on amps when you're dealing with your system, your distribution in your factory or building. It can be a significant cost saver when it comes time to change or install equipment. So here's a little cheat sheet or guide for you that you can have, a quick reference guide. You can post it, keep it handy, put it in a wallet. Some people like the step process, so here's step 1, step 2, step 3, step 4. Or if you like the algebra approach, watts divided by 1,000 times hours times the price. This is now the formula we can use to calculate the cost of energy of any particular piece of equipment or a system or a room or a building. So let's do a little math example, how we'd use this formula. And you can use your arrow or other tool to mark which answer you think it is. What are the power costs for lighting in this office area each month? I've picked kind of one room. Office area has 40 fluorescent fixtures. Each fixture has 2 lamps at 45 watts each, so we're talking about 90 watts per fixture. The lights are on 10 hours a day, 7 days a week. 8 cents per kilowatt hour is the price. Assume 30 days in a month. As you can tell, managing energy and calculating energy costs is like solving word problems in school, which were not my favorite things, but I learned to get good at them because life is a word problem. No one hands you the formula and the variables and says calculate. You have to figure out what are the important elements I need to answer the question. Looks like we've got some answers, $86.40. A couple different choices. Let's see how I answered this. I took the watts was 40 fixtures and 90 watts each. You divide by 1,000. The number of hours is 10 hours a day for 30 days, which would be 300 times 8 cents. And if my calculator works right, that's $86.40. So let's look at another math example, and this one I'll just walk you through it. A customer has a choice between 2 air conditioners. One uses 1,200 watts and the other one uses 1,000 watts. And of course, the one that uses less energy, you might have to spend more for it. The air conditioner is 6 hours a day for 4 months, assuming 30 days in a month. The cost is 10 cents. I like 10 cents because it's easy to do the math. How many years will it take to pay back? And this is a measurement term for managing that is universal. Almost all customers know about how to calculate a payback period. How long does it take to get my $100 back, which is what the budget manager is going to ask you. If you want to spend more money than you need to, why? And one of the answers is because you get your money back fairly quickly. So let's look at some of this math. I find how many watts of savings am I going to get between these two? Well, one's 1,200, the other one's 1,000, so I have 200 watts of savings. I divide by 1,000 to get 0.2 kW. My hours of operation are 4 months, 30 days a month, 6 hours a day. I have 720 hours. Now I can put my formula in place, 0.2 kW, 720 hours times 10 cents. I save $14.40 a year. Now I can do my payback period. If I have an extra $100 out of pocket and I get $14.40 back every year, that's 6.9 years to get my money back. About 7 years. This is beyond any payback period tolerance I've heard from business customers. I've heard numbers of 3 years is my rule of thumb, sometimes 5 years. If you're a restaurant or other business that can't think long-term, the paybacks may even be 1 year or measured in 18 months. So keep track of payback. It's a very good first step tool to see whether your project is viable. Now let's look at what the utilities or the Energy Trust might do in saying, wait a minute, we want you to save this energy. We'll give you an incentive. So what changes if you get a $50 rebate? Well, this changes it quite a bit. Now instead of the payback being 7 years, I have $100 minus the 50 divided by that 1440. I'm down to 3.5 years. So you can see incentives are a great way to use to get projects in a zone where you can get the project approved and get financed. So let's look at one more example, and you can use your arrow tool or tool of preference. Let's look at 2 bulbs, and this is an actual example I saw in a store. Both the bulbs are the same watts. They both produce the same amount of lumens. Light is measured in lumens. One bulb was $4 and one bulb was $5. So if you're only looking at watts, you'd think, well, let's go with the bulb that's cheaper. But you got to read the label. The $4 bulb had 8,000 hours of life on average, according to the label, whereas the $5 bulb had 12,000 hours of life. So if I asked you to purchase 100 bulbs, which CFL would you purchase? So take a quick guess. Show me which one you might do. Well, I'm getting a split, and that's about pretty common. The more your business has to think short term, you're probably going to get the $4 bulb. The more you can think long term, the more likely you would say, let's step up to the other bulb. So here's how I looked at this. I took the $4 bulb and $5 bulb, and I asked, well, how many years will this thing last? And so I made an assumption of 10 hours a day for 365 days. And you could pick a different one, but pick your hours of use, and you're going to find that there's quite a bit of difference between these two bulbs. In this case, one lasts 2.2 years on average, the other one lasts 3.3 years. Now you can say, well, over 6.6 years, I would have had to replace the first bulb 3 times to get to 6.6 years. So I'd spend the $400 3 times, $1,200. If you buy the $5 bulb over the next 6.6 years, you only have to replace that bulb twice. So that's 2 times $500 or $1,000. So you save $200 by buying the $5 bulb over time. So if you're that property manager, you're probably going to think longer term if you can and buy the bulb that has the longer life.
Hi, John. What are some other benefits to a longer life bulb besides cost savings? Are there any?
Yes, I've had customers remind me that in the commercial industrial sector, you are required to recycle compact fluorescents, and if you can postpone that recycling cost by up to a year in this case, that can be a significant savings. The second thing that people have talked to me is maintenance staff. Quite often, labor exceeds the cost of the bulb. So again, if I can postpone the replacement of the bulb, I save on labor as well. So labor and recycling costs are probably 2 very good extra benefits of this project. So let's talk about measuring. You've now got ways to calculate, you've got bills you can track, and this is an example of just looking at monthly bill statements over a period of 4 years. And the first thing I did was to put the winter in the middle. Now this is a more residential type style bill here, and by putting the winter in the middle, it makes it clear about where is your focus. Well, it's the high winter peak. Now, if you're a summer peaker with air conditioning load, put the summer in the middle. So I'm saying adjust your chart to what makes most sense. And of course, what we have here is 2 older years, the winter of 2003 and 4, 4 and 5 are up here. So here's winter, and then I have the next 2 years, 2005 and 6, 2006 and 7 are down here. So here's winter, 2 winters before and 2 winters after something was changed. In this case, it happened to be a heat pump system, and we went with a very efficient unit compared to a standard efficient unit. And I was surprised that we got a 40% decrease in our high bills. So all this energy here went away. I saved all that and got down to this. So this is a pretty interesting way to look at decision making, especially if you're in business, commercial or industrial, and you need to show, gee, thank you for funding my project. graphically is very powerful. If you showed this in a spreadsheet with columns and rows, it wouldn't be nearly as impactful. So I highly recommend, as you're tracking your energy costs, use graphics to help everyone see what's going on. Likewise, if bills were going up, you could show this chart saying, gee, we need to do something because we have increasing costs every winter, which may be a sign that you need to do more maintenance. Here's another chart, one that was given to me. This is a customer who has an energy management system, and which means they can measure electricity every hour, every half hour, very small increments. They call that interval data, and they put it at, it's a 24-hour clock. So right in the middle here is noon, and then at the two ends you have midnights. And they took 30 days and mapped one on top of the other. So when I first saw this graph, I went, whoa. But as soon as you start explaining it, you go, oh, I'm starting to get it. So this happens to be a school building. So Monday through Fridays, you see this nice shape. And then they told me down here were Saturdays, and up here were 4 or 5 Sundays. So now that makes more sense. And what I like about these kinds of graphs is you can ask very smart questions without really having a detailed knowledge of the system. And here are the 3 that I was told that this customer used to get after energy savings. The first thing that came to mind was, why does it take so long, if this is a school, for that energy to finally go back down to what it is at midnight? If the school classes are let out at 3, 4, 5 o'clock, it shouldn't take that long. Well, it turned out that it was a janitorial service. They were turning all the lights on in all the rooms, and as they cleaned them, they would turn the lights off, and that's how they kept track of which rooms were being cleaned and which ones are already done. That might have worked well for the janitors, but it took a long time before all the energy was off. So they renegotiated and found a different way for them to keep track, and this shape changed and really dropped down fast. And so they saved all this energy in here, got saved. So again, the shape can allow you to ask smart questions. You get an answer, you can make changes in your process and save energy and see the difference on the next set of the next month's charts. Another question they asked was, what comes on at 1 a.m. and runs all night? This shape right here, every night, Monday through Monday, a little bump in the night. And they didn't get any answers right away. And finally, someone from the IT department said, oh, that's my computer backup program. It turns all the computers on and backs up the disks. And the facilities manager asked, does that take all night? And they said, no, it only takes about 35 minutes. But the software they have wasn't smart enough to turn the computers off. He got a really good deal. He only had to turn them on. So the facilities manager said, look, I'll buy you the better software. Well, let's get this thing to shut off so I can save this energy down here. Get rid of that. Change the shape. So talking energy by its shape can be very productive. The last thing they learned from this chart was, why were Sundays higher than Saturdays? And that became evident fairly quickly, that they were renting the facility out to a Sunday church group. Well, now they have a way to know, am I charging enough for the room to cover the energy costs? They can look at the difference between the Sunday and the Saturday and say, that amount I better get revenue for. So they didn't change the shape, but they could figure out how much they have to charge for that amount of energy to make sure that the rental was more than covering the costs. So these are 3 really good questions that came from overlaying 30 days on top of each other and asking some questions. Now your baseline may be, I want to see this month versus the same month last year, or let me see what's happening every Monday. And then suddenly a Monday jumps out as something very different's happening. So shape can really be a useful tool in measuring and managing energy. So in summary, I would kind of focus on 3 types of possible change. One is you can change the behavior. Conservation, don't waste it. Maintenance of equipment. We talked about changing the behavior of when you leave a room, turn the lights off. Secondly, you can change the process. We talked about the process of the janitors and what they were doing. You didn't change the equipment, you changed their process and significantly can reduce the energy. And finally, you can change the equipment. And the purchasing decision is when you lock in the wattage. Again, watch out for efficiency, watch out for the life of the bulbs or the life of the equipment. These can be very important factors that lead to higher bills than are necessary if you can purchase the most efficient equipment in the first place. So what are your next steps? Start measuring, start graphing, get some kind of feedback system so that when you do make changes, you can see the difference. You know what you're doing is working. Or asking intelligent questions. Compare that energy use with some kind of benchmark or baseline. This year, last year, this Monday, same time a month ago. There are industry standards of kilowatt hours per square foot for office buildings. Again, get some help from people who know what those standards are. Develop and maintain a list of project ideas. We saw one project that had a 7-year payback, but as soon as there was an incentive, it changed the payback to within the guidelines. So just because you have a project that's no doesn't mean never. You should keep that list alive. Check every 6 months or so to see if the price changed, if there's a new incentive. I mean, there's federal, there's state, there's utilities, constantly changing what kinds of incentives are available. And finally, keep learning. Stay abreast of changing technology, prices, incentives. The technology is changing, getting better every year, and it's very wise to sit down every 6 months and check it out. So with that, I told you I would leave you with the best advice of all is give someone a call. Here's Paula, sits on our floor, and Darren Spencer sits on our floor here at PGE. They are very well knowledgeable about the Energy Trust and other incentives and programs out there. Be glad to talk to you on the phone. They are surrounded by engineers, lighting specialists, all kinds of people who are ready to help you with your project and give you some advice and some help. So with that, I will turn it back to Beth, and we'll maybe get some questions.
Thanks, John. Before we proceed to the question and answer portion of the webinar, I'd like to remind you that you can still submit questions to me through chat, and I will ask them of John. I'd also like to draw your attention to a survey poll that I just opened in the lower right-hand corner of your screen. If you could take a few moments during question and answer to fill this out, we would really appreciate it. We value your feedback, and we do use it to improve future webinars. And now for our first question, John, where do you find the information about watts used for a specific piece of equipment? And where can I find lists or information about similar equipment and the wattage used by this equipment?
Well, the first place I would start is with the Energy Trust of Oregon website. If they are offering incentives on different types of equipment, they will tell you exactly the efficiency ratings that qualify. And sometimes specific pieces of equipment. Energy Star, the federal government's website, has some really good information on which appliances and which equipment is most efficient. And the more industrial or process it is, you may have to give Darren a call and actually get to an energy expert engineer who has some knowledge of the current state of systems and what's coming.
Great, thanks, John. And our next question is, you mentioned talking to purchasing managers about costs and length of use in your math examples. Do you have any suggestions for how to talk to the purchasing managers, what I should be showing them, ask the participant?
Absolutely. Two things I suggest. We, every 2 years, and it's going to be this year, maybe around June, we'll have a CFO Perspectives of Energy Efficiency and Renewables, a half-day seminar. I believe we might even run a webinar in front of that about the language of CFOs, which would include the purchasing type logic. But more importantly, if you don't know who your purchasing manager is or don't know them well enough, take them out for a cup of coffee, go have lunch, ask them questions about what's the criteria are for them purchasing. I think that they will be glad to talk to you about it and work out the best solution for your company. So have a dialogue. The numbers we have here today will be fine, and then come to the seminar.
Great, thanks, John. And we'll let you all know when that seminar will be when we get it finally scheduled. Let's see, it looks like our last question you may have already answered, but are there resources or websites where you can find the best rated equipment?
I think that was already asked and answered. I would start with the Energy Trust of Oregon. If they don't have that listed, they have a list of trade allies which are authorized to determine what pieces of equipment would get incentives and not. Other things like the motors are going to have the efficiency ratings right on the labels, but I would definitely go to call Paula or Darren or go to the Energy Trust website.
Great, John. Thank you. That was our last question.